and welcome back to my channel, and also welcome back to the third episode of this series, Properties of Sets. If you haven't seen the first and the second episode, I would really recommend you to see those two and then come back here, because mostly everything you'll see will be unknown to you if you haven't watched this before. So before we dive straight in once again, I would want you to hit the like button, hit the subscribe button, ring that notification bell for more videos like these. And I'll see you in another video then once I finish this one and you want to see more. And it's always helping me, and I really appreciate it when you do that, as well as you enjoying this video. Again, I really appreciate it for you doing that. So please hit that subscribe button, hit the like button, ring that notification bell, and we can continue. Properties of sets. So the first property we're covering is the commutative property. It states that the union of A and B is equal to the union of B and A. This means the number of elements in the union of A and B is equal to the number of elements in the union B of A. And also what the elements are will definitely be equal. The union is, if you don't remember, the amount of elements that are in both A and B. Not the amount of elements, the elements that are listed. You basically put them in a list, all the elements of A and B. And in the same way, the intersection of A and B is equal to the intersection of B and A. It's fairly simple now. And then we cover the difference of sets as well in the last episode. And A minus B is unequal to B minus A. This is because here, in the A minus B, we're taking A first. So we are not going to take all the other elements of B. This is not like intersection. This is different. And so it'll be different from B minus A, where we'll take all the elements away from A that we don't need. And also we have the associative property. You can say that A union B union C is equal to A union B union C. So no matter where you put the brackets in this case, you will always have the unions to be equal. And also, you also have the intersection. A intersection B intersection C is equal to A intersection B intersection C. This means the same thing technically, but only with intersection. Fairly simple still. Then we have the distributive property. And then A union B intersection C is equal to A union B intersection A union C. This may look, you may not understand why, but the reason is, and if you understand it, well done, is because you just have to distribute it. You can just write, if you want to remember, you can just write A union, then put the B. Then in the middle, put the intersection, because that's in the middle of B and C, and you take A union C. Now, then you just get A union B intersection A union C. This also happens with the opposite signs, you could say, for A intersection B union C. It's A intersection B union A intersection C. And remember, this is not the number of elements now. This is everything. It'll definitely be equal. Then we go for the complement law. The complement law is basically what we also covered in the complementary sets and their properties. But here, A union A dash is equal to A dash union A is equal to the universal set U. As I said before, it doesn't always have to be P. In this example, it's A. It can be any variable, as I've said before. So, and we also said that all the elements in the complement of a set, all the elements in the universal set are there in the complement of a set, except for the elements of that set. May sound confusing, but again, we can say if A is 1, then A dash will be all the numbers that are possible to go into a set except for 1. So obviously, if we said A dash union A is equal to the universal set, that's technically right, because that means all the elements in the universal set are together. And there is no intersection as well, which is why we can say A dash intersection A is equal to phi, which symbolizes an empty set or a null set. The fifth property you would want to know is the idempotent law. It says that A union A is equal to A and A intersection A is equal to A. This is also fairly simple. Because imagine we can use Venn diagrams for this representation. Imagine one circle and we call that A. Then what is A union A? If you simplify that, you're basically asking what are the elements between A and A? That's basically what are the elements between A. So you can just say A, the set A itself. The same will be for the intersection, because if you have the two same sets, all the elements would be equal. So A union A is equal to A and A intersection A is equal to A. Sorry, not equal. Intersecting there will also be there in A. And then finally for this number 6, the null set and the universal set law. Phi dash is equal to U, phi is equal to U dash, and U dash is equal to phi while U is equal to phi. U is equal to phi dash, phi dash is supposed to be there. So technically, U is equal to phi dash is also written up there with phi dash is equal to U. But one column is for phi, starting with phi, and one column is for the universal set. This basically means that the complement of an empty or null set is equal to the universal set, because if you have nothing in one set, then its complement would be everything, which is the universal set. You can use that same logic for saying that the complement of the universal set is an empty or null set, because if you have everything, the complement would be nothing, which is phi, again here. Then we have the De Morgan's law. We have two laws here, the law of union and the law of intersection. The law of union says that if you have A union B, the whole complement, which means that you complement both of them, that will be the same as A dash intersection B dash. And the law of intersection is the same thing, but it goes in the opposite way. You say A intersection B, the whole dash is equal to A dash union B dash. Now, basically, if we're saying the whole complement, then we mean that we would take the union of A and B and take out all of those elements and then only take the elements that are left in the universal set. And then we can say that that is equal to the complements of the two sets intersection. So if you didn't understand that, you can just remember if you see this. And to remember it well, you can say that A union B, the whole dash. If it's a union and it goes inside there, it becomes intersection. And if it's intersection, it becomes union. Though just know there is no such thing like this. This is just like something to help you remember this. So if you don't remember any of the properties or you want to keep revising, I recommend you to also go back to the slides that we said before, but we can go on to the end. I would like you to thank you for watching all this way, and I would like to thank you for listening. I would like to thank you for everything here. But the only reason I made this series is for you to learn. So the last episode that we're doing next time is going to test that. So before we go, I want you to please click that like button, click that subscribe button, and ring that notification bell for more videos like this. And I'll see you there. Goodbye!